Greetings, everyone. Tonight is the December meeting of the Houston Astronomical Society Novice Meeting. My name is Chris Morissette. For those of you that don't know me, I'm the Novice Chair. And we have, I think, a really good program tonight. Last month, we saw a really cool presentation by Will Sager and Steve Goldberg and Joe Califf about how to pick out the right telescope. And tonight, what we're going to do is kind of provide a supplement to that and talk about night and astrophotography, a universe of possibilities. So I'm really, like I said, I'm really excited about the presentation tonight. Um, what we want to do in this presentation, obviously, night photography and astrophotography are complicated hobbies, so it's impossible to get you really far down the line in an hour. But what we are going to attempt to do is give you some great solid information on how to get started. We'll give you some uh, uh, panelists that we've got on the Zoom call here tonight to walk you through the equipment that they used and the great images that they produced for night photography, for astrophotography, and for some other simple and novel techniques. And then we hope that as we go through this, you log your questions into the chat, and we'll come back to that at the end of the presentation and we'll go through those questions. I would also like to ask if you would go on mute while we're in progress here so that we don't get any sound interference. But but do ask your questions and we will certainly make time to come back and discuss those. I just want to point out a few prefacing comments. Image processing will not be in the scope of this presentation. It's very complicated and really deserves one or two meetings all on its own. Used equipment can be procured at a discount. If possible, try before you buy. And what I mean by this is if you go to a vendor or a store of any kind and you buy used equipment, make sure that they have a return policy that allows you to bring the equipment back in the event there's an issue. Consider this presentation as a starting point, then do your own homework. There are just so many combinations of equipment and types of pictures that you can take that it's really impossible to cover everything here. I did receive a lot of great images. Unfortunately, I wasn't able to use all of them for this presentation. So I apologize for that, but I do appreciate all the submissions that were made. And there is no need to take notes. We'll provide a way for you to get a copy of these slides for your files. As a matter of fact, Heather has already posted in the chat a link that will take you to a Google Drive that does have the PowerPoint presentation as an Adobe file, and then there's a couple other files in there as well. So just kind of sit back, relax, and kind of take it all in. Let's talk about getting started. Um, when you first get started in this hobby, it can be bewildering. But what I would recommend is that you really want to do is just ask yourself some important and basic questions before you dive headfirst into the hobby. First, what kind of photograph do you want to take? Do you want to take Milky Way or Starry Night pictures with an interesting foreground? So if you are a landscape photographer by day, this might be a logical move for you to move into night photography like that. If you're more astronomy centric, and into the science, so to speak, what kind of deep sky objects do you want to image? Do you want to take wide field images, such as Andromeda or Pleiades or open star clusters? Are you more interested in small deep sky objects like globular clusters or planetary nebula? Or are you interested in imaging the sun, the moon, and the planets? The answer that you give to get to these questions will take you down a different path in terms of, the type of equipment and the type of uh, techniques that you're going to be employing. What are your objectives? Do you want to take inspirational pictures to show friends, family, or post on social media? You want National Geographic quality images, or are your pictures more for, say, teaching or for instruction or for something that is educational in nature? The quality of the image in that case really doesn't need to be as high as it would be for taking, an inspirational or artistic picture. Not to be left on the wayside here, but how much money do you want to spend? This hobby can be extremely expensive if you want it to be, or it can be done on a budget that
Mm.
would fit within your means. But you really need to have a hard talk with yourself about how much money do you want to spend. And we'll give you some ideas on what the entry cost is going to be. And then just as important, what amount of time do you want to spend on this hobby? Um, is designing, assembling, and troubleshooting a system something that you would be willing to spend a lot of time doing? Is it something that you have an aptitude for? Traveling to dark locations or places with an interesting foreground. Are you a traveler by extension anyway? It's another interest that you have, so this would be an adjunct to that. Or is this something that would be new to you? So, time and money are two big things that you need to consider when you're getting ready to jump into this hobby. Now, as far as help is concerned, once you've kind of gone through those questions and figured out a path you want to go down, HAS has a lot of great information, a lot of great resources. So, just in the area of photography help, we have two special interest groups, the Astrophotography Special Interest Group and the Smart Telescope Special Interest Group that meet um, on, I think, the third and fourth or second and third Wednesday of each month. These are a very informal collection of folks that are into astrophotography and smart telescopes. They meet via Zoom, and you can dial in and ask questions and get help via that group. Discord is um, another resource that you can tap into. There you have various chat groups that would talk about photography, and you can get into that like you would any kind of chat thread that you may see on another service and get the help that you want from HAS members. Attend a general meeting in person. I understand we may have some issues with the January meeting, but the next in-meeting, general in-person meeting, it'd be a great opportunity for you to meet other folks and talk about photography in a more informal setting and really put a face to a name. Finally, if you need some more one-on-one help, mentorship would be available. You can request a mentor by emailing members at astronomyhouston.org, and you can get some one-on-one help. So that's kind of the people part of the help. The dark site is a resource that we have as a club, a wonderful place to go. Dark skies, utilities there that are really geared for, in particular, astrophotography. So that's a great resource. Our loaner program for telescopes is another way to get started, and I'll show you an example of how I was able to use a loaner telescope to kind of get my foot in the door on some imaging. And then used equipment for sale. That is, there, people are always selling equipment. You'll see notices come from members. And again, another place that you can look to try to get equipment that would fit your budget. Outside of HAS, uh, this is not an all-inclusive list, but some resources that I like and others on our panel have recommended. Um, Astro Backyard, who that is it's a YouTube channel run by a guy by the name of Trevor Jones, and Trevor does a really excellent job, I think, of breaking things down and giving you recommendations and test runs of equipment. Does a wonderful job. Nebula Photos is one that Matt Borlange had suggested, and I haven't used it myself, but Matt has recommends it and certainly would be worth checking out. And in cloudy nights is another one, although that tends to be a little bit of a dog's breakfast. You've got kind of information flying all over the place. So you kind of have to kind of get your bearings on that one before you can really make some good use of it. Here are some books and references that you can tap into. I won't go through these line by line, but there are many books out there. These are a few that myself and our panelists have recommended. So you might want to take a look at those. And again, you'll be able to get access to the PDF copy so you can get the list from there. And then purchasing equipment. Um, for night photography, here are four that are really good. The Houston Camera Exchange, which is here in town, is great because you can order via mail order or you can go in person. And it's always nice to be able to talk to somebody and get some help. They sell both new and used equipment. I bought personally new and used equipment from these folks, and they have a robust return policy, so you don't have to worry about getting stuck with something that doesn't work. B&H Photo is a big outfit up in New York. They're kind of a mail order outfit, for lack of a better term. Again, really good service and both new and used equipment. MPB and KEH Camera are two resources that are deal in used only equipment. So you might want to consider those as you're going out and pricing equipment. And then in the astrophotography area, of course, our own Land, Sea, and Sky is a resource that we have here in town. You can go in and talk to people. Um, High Point Scientific is another one where I know a lot of members, myself included, have tapped into these folks for cameras, filters, etc., you name it. And then the Woodland Hills Camera and Telescopes is another retailer that's online. Again, not an all like inclusive list here, but just a few names to kind of get you in the game, so to speak. So with that, we're going to pivot now and talk more about the equipment configurations that we're going to be presenting tonight, and I'm doing that in a bit of a summary level right here, but we'll go into detail here in a second. So we're going to cover three broad categories here. We're gonna talk about some simple and novel photography types that you can kind of get your toe in the water with. We'll then delve into night photography, nightscape photography, and hear from three of our panelists about the equipment they use and the images that they've taken. And then we'll delve into astrophotography. Here we'll talk about smart telescopes, which has been a big interest among a lot of folks. Um, we'll talk about DSLR cameras coupled to a telescope, and we'll talk about astrophotography cameras coupled to a couple of different types of telescopes, and also a kind of a novel setup where a astrophotography camera is coupled to a telephoto lens. So that's going to be kind of the scope of our presentation tonight. The last column over here on the right is called notional entry costs. Now, I tried to get ranges that we could communicate to you as a group, but the ranges are just so wide and varied that I thought just kind of giving you an idea of what the entry, the bar is for getting involved in these different of um, of camera and photography types. So I thought that would just be a good way to start and then let you build from that. Cell phone, we're assuming that everybody has a cell phone, and so we really kind of put that cost as zero. I know we weren't going to talk about software or post-processing of images, but you are inevitably going to need software. So we put this table together of common software packages that you're going to need at some point or another in your pursuit of the hobby. The top line is for post-processing, and here you see the two entrants from Adobe, Lightroom, and Photoshop, and then on down the list here, you see other types of packages that you'll need to use. or can use when you're developing deep sky images or planetary images. All right, so with that, let's dig into the nuts and bolts here, and we're going to start out with some simple and novel um, uh, uses, or simple or novel ways to take images. So the first one you see here is it's a cell phone image of the Milky Way, one of mine that I took out in West Texas at the McDonald Observatory. This was just a point and shoot. I did not have a tripod. I did not try to set any of the camera settings at all. The data that you see over here on the left under camera and settings is just what I took off the picture. And not a wow picture, but just a picture to show you that, hey, even with a simple cell phone, you can get a picture of the Milky Way. Yeah, it's not a knockout, but at least it helps you get started. And if you were going to use this for any kind of educational purpose, yeah, it might fit the bill for you. But that's a simple, easy way to dip your toe into night photography. This next one here is a cell phone image from a friend of mine up in Redmond, Washington. He took this last May during the high activity, the high aurora activity. And again, he was just pointing and shooting. And again, the camera settings that you see here on the left are what I took off the picture. But he just pointed and shoot and shot. He uses a Google Pixel 7, and I must tell you, this is very impressive picture of the aurora. So just a couple of easy, quick examples to show you that even with your cell phone, you can get out there, when we get a clear night and start experimenting around. This next one is a solar can from Heather Sharon. So Heather, if you'd come off mute and tell us all about the solar can.
Yeah, so these are from a company based in the UK. Um, it's kind of what you did in elementary school, where you take a can and you put photosensitive paper behind it, and then you just expose it to sunlight. When you buy them on the website, Solar Can, it comes with everything you need. The little can has the zip ties, it has the photosensitive paper already set inside with little brackets, and all you do is pick a spot and leave it there. People are going to ask you why you have beer cans zip tied to your railings. That's okay. But the longer you leave it out, the better. You can get some really, unique perspectives, different places. It's actually really, really sensitive too, because if you can see the bottom picture, that's actually, you can see the sunlight reflecting on the lake too, was captured in the photo paper. So that's kind of cool. And you can see in the top one when we had like weeks of clouds, there's no trailing. And then basically you cut the can open, you take your paper out once you're done, scan it on just a regular scanner, or you can take a photo of it, and then you just invert the colors, and that's it. I mean, you don't have to get it developed or anything like that. It comes out of the can ready to go. And have fun with it. Do whatever colors and processing you want. So you can also get ones that are called pucks, that are like a smaller circle, and it has one hole on top. And those are for like, 1 or 2 day exposures. But yeah, there's some pretty cool ones that put them up for like an entire year, but I didn't have the patience for that. So
All right, great. And I understand they come in different colors as well, correct?
yeah, so this one is just like the bare bones basic. You can get ones with different types of photo paper that's like more neons or whatever. But basically it comes out, it looks kind of pink and purplish, but it's because it's a negative essentially. So when you scan it and you invert it, then you get the other color. Um, but yeah, you can do whatever colors you want if you use Photoshop or Lightroom. Pretty much it's it's really creative. It's a lot of fun.
Excellent. Thanks, Heather. Appreciate that. This last one in the simple novel area is one that I had put together when I first got enthusiastic about astrophotography. I borrowed this white Meade telescope. It's a 6-inch diameter telescope, a reflector rather, excuse me. I bought the camera up in the upper left-hand corner from my son-in-law. Bought these little fittings that you see down here in the lower left and middle bottom pictures which is kind of what they call a bull nose, and that actually replaces what a lens would have. And then that allows you to stick it in the focuser of the telescope, which you see in the upper right-hand corner picture. And what you do here is you take a video. So I took a 30 frame per second video, and this is what I saw coming through my viewfinder. And you're not tracking at all with this telescope. It's just a simple Dobbs telescope, and you're letting the moon, in this case, um, uh, flow through or glide through your field of view. And then what you're able to do with that once you're done taking that video is you can come in and process it kind of like a series of pictures that you would take in traditional astrophotography. And you would use software like AutoStacker to actually pick out the best frames and to stack them and make a crisper, clearer image. And for a video like that, you got a lot. I think you get a lot of neat detail on this thing. You can see Mare Crisium and some of the craters, and I just thought it was a very uh, cheap and effective way to, get in and start doing some cool stuff with astrophotography. So anyway, I just wanted to show you that. Okay, so that was our simple novel set of uh, of entries, exhibits we wanted to show you tonight. Now we're going to pivot to night photography, and with that, I'm going to turn it over to Bob Menius. So, Bob, if you'd come off mute, you have three slides here, and I'll let you kind of walk us through. And when you're ready to go to the next slide, just cue me.
Okay. Um, I've got three pictures, and I'll start by saying that I think it's a good idea to begin astrophotography by using what you already have before you go out and buy new stuff. In my case, I already had traditional photography as a hobby for several decades before I decided to try astrophotography. So I already owned good cameras and lenses that I could use and had to buy essentially nothing to do these pictures. Uh, all three of my pictures are what you'd call relatively simple compared to other types of astrophotography. They are simply camera and tripod pictures, no tracking, no guiding, no telescope involved. And the kind of equipment you need to do this for all three of my pictures would be a single lens reflex or mirrorless interchangeable lens camera and a lens, obviously, a reasonably sturdy tripod, some kind of photo editing software. I happen to use for these pictures Photoshop Elements, which is a simplified, less expensive version of the full Photoshop. And the last thing you need is some kind of resource or experienced friend to teach you the basics. This is not an absolute requirement. Some people do it totally alone, but I think someone to help you get started is a great idea. Uh, my personal favorite, who's not on Chris's list, so I'll tell you a little bit about it. My personal favorite is someone named Alan Dyer. That's Alandyer. He is a Canadian astrophotographer who has a website, at www.amazingsky.com, and he is, in my opinion, excellent for beginning and intermediate astrophotography. Not only does he know a lot, but he's a great teacher and explains it quite well. So I highly recommend Alan Dyer. This picture you're looking at of star trails is, as it says to the left, a combination of 279 separate exposures. That number of exposures was determined by my battery life in my camera. I set the camera up to do this with a fully charged battery, and I took pictures. About 5 hours later, the battery died. So that's how I got 279 exposures. Each exposure was a 1 minute exposure. I determined that by trial and error, looking at the histogram and doing what Alan Dyer recommended. To process it, I first processed one frame by itself in Photoshop Elements for brightness, contrast, color, and so forth. And then I automatically batch processed the other 278 frames in Photoshop Elements. I just sat back and watched it do its thing for the rest of the frames. At that point, I combined the 279 frames with a free piece of software called Star Stacks, also recommended by Alan Dyer. And the result is what you see. There are a few, I think, interesting things to notice about this picture if you look closely. There is a small meteor underneath Polaris, about halfway to the ground, just a little bitty streak. I was actually surprised I didn't get more. Um, Also, if you look at the lower left corner, there are some streaks. Those are airplanes taking off and landing at a nearby airport. This was at the 2015 Texas Star Party out in West Texas. The total time for this was slightly less than 5 hours. And I'm a retired teacher, so I like to use my photographs for teaching purposes sometimes. This one, for example, I would pose the question, how can you look at this picture and with a simple measurement or two determine the total exposure time? And as most of you can probably figure out, it's based on the fact that 24 hours represents 360 degrees worth of rotation for the Earth. And so all you have to do is get a protractor, let Polaris be the vertex of the angle, measure the angular distance of any of these arcs. They'll all be the same, and simply compare your angle with 360 degrees for 24 hours. Uh, and it's most students can figure that out if they understand that the rotation of the Earth is in fact causing these star trails. A lot of photographers would take this kind of picture and use Photoshop to put in a scenic foreground. But I really like the crazy red lights at the Texas Star Party. And I even like that strange looking solo chair in the lower right-hand corner. I didn't know that was there until I saw the result. Okay, go to the next picture. This also is just a camera and a tripod kind of shot. But it was planned. It was not accidental. I knew by using the internet or a magazine like Sky and Telescope where the moon and the comet would be at this particular time. The previous picture with star trails used a wide angle lens, 10 millimeters. This one used a telephoto lens, 250 millimeters. I simply put the camera on a tripod. I adjusted the zoom lens for what I thought was a good composition. I included some foreground at the bottom, which is usually a good idea. I shot a whole bunch of different manual exposures, knowing that extra exposures with digital, lots of trial and error is free, unlike film. I selected the best exposure. I adjusted it slightly with Photoshop, and I got the result that you see. It was not dark enough to see any stars, but seeing the comet and the new moon and the colorful sunset made it a picture that I like even without stars. Okay, next picture. This is called trying something different with a lens I already owned. As most of you probably know, a fisheye lens is an extremely wide-angle lens with a 180-degree field of view in all directions, so you get a circular image. And what I did here was put my camera on a tripod with a fisheye lens pointed straight up. And by pointing the lens straight up, I got to see the complete horizon 360 degrees around the edge. You can tell from the text I added that I also have used this picture for teaching purposes. I put a novice question in the lower left corner, and I put a more advanced question in the lower right corner to take care of different grade levels and different students that might see this picture. Okay, those are my three pictures. You can go ahead, Chris.
Well, thank you very much, Bob. Next, we've got Heather Sharon. So, Heather, if you'd come off mute and tell us about your equipment and your picture.
So this was my first foray into also doing Milky Way because we had clouds all summer and I was tired of the not being able to use my telescope. So basically I have a DSLR, it's a Canon EOS 1100 that I borrowed from my mom a while back and then sent it off to get it Astro modified. So I kept it. It's mounted on a Nomad. It's a Move Shoot Move Nomad star tracker. It's just basically a little box. It's battery powered and it goes in the opposite direction of the sun, or the stars. So you just mount that. It's got a little Z plate so you can have the right angle, do a rough polar alignment, and then you can just basically use the ball head attached to the tracker to put the camera wherever you want it. It's a wide angle 14 millimeter lens. I got it from MBH used for like $120 basically. It's like brand new, but I knew because I just got something used, so I didn't know if I'd like it or not. And then I have no filter in the camera either. And the tripod is just a cheap, like old Amazon knockoff, but you can't see in the picture, but I have a big old jug of water hanging down the center to help stabilize it. So if you want to go to the next one, I think that has the picture. Yeah. So basically when it was dusk, I took a picture of the foreground, which is the grass and the dunes. And then basically pointed and shot for a while. I didn't know what exposures to do or ISO or anything like that. So like the previous one, I just did a bunch. I got lucky and caught a couple of Perseids. You can see them on the right side. So yeah, it's just a bunch of 30-second subs, stacked them in PixInsight, went into Photoshop to do, they have a really neat application that lets you basically attach a background and a foreground, kind of like identifies it for you and helps you do that. There's a bunch of YouTube tutorials on how to do it because I didn't know either. So it's a lot easier than it looks. And then to add the frames that had the meteors, I just did layers in Photoshop and made those visible on top of them. And so this was my first attempt at it. So if I can do it like that, it's not as hard as it should be, I guess. Just go to YouTube and there's a ton of them out there that'll help you work through it. And yeah, it's a really old camera, a cheap lens, and a cheap tripod and dark skies.
All right. Well, thank you, Heather. Move on.
It's
Oh, I'm sorry. Yeah, did
no,
you want to say? Go ahead. No, did you have anything else?
no, I'm done.
Oh, okay. Real good. All right. Peggy Mueller is our next contributor here. So, Peggy, if you'd come off mute and tell us about your equipment and the two images that you've taken, that'd be wonderful.
Yeah, so hi, I'm Peggy. So I have a Canon 6D Mark II, and I've had it for probably 6 or 7 years, and I love it. And I never meant to take any kind of night images with it when I first bought it. I'm mostly landscape kind of photographer, but started getting interested in at least attempting something with a fairly cheap setup. I think the only thing I bought to do Astro was the tracker. So it's a Sky Watcher Star Adventure and wasn't too expensive, and it's reasonably light so that you can stick it in your suitcase and take it with you. The lens was actually that so yeah, I should have said this. The lens I did buy for Milky Way. It's an expensive lens. You don't have to have that. The one that Heather used, that Rokinon 14, is a really great lens to start with because it's lower cost. But when you get addicted and you want a really good lens, the Sigma 14 millimeter f 1.8 is awesome. Okay, next slide, please. Okay, so this was the first Milky Way photo that I actually liked that I took. And really, most of it was because of where I was. So like I said, I like landscape. This is at La Palma, which is an island off the northwestern coast of Africa. And this is a collapsed caldera. It's a volcanic island, very much like a tiny Hawaii, sort of. It's only 1.5 million years old. There's some one active volcano on it. And this was cloud filled. And so pretty much my camera settings that are up there, 4000 ISO, 13-second sub, and f1.8. The one thing I should mention is a lot of people let their white balance stay on auto, but I was told that it's better to set it. But every camera needs a different setting. That's the trick. And so I had this one set at 4000 Kelvin. And when I looked at the image and I saw that green glow at the bottom, I thought, oh my goodness, this is not a good, 4,000 isn't good. But actually, that green glow is air glow. You may already know that. So it's actually beautiful. I think it's the only photo of the Milky Way I have that has that beautiful glow. Oh, I should mention this island is really perfect. The whole island is Bortle 2 or less, and it's got great telescopes on it. It has there's an observatory called the Road de los Muchachos Observatory. It has the world's largest optical infrared telescope. So not only can you take really beautiful dark sky, but you can visit the telescopes and take a look at their observatory. So pretty cool. I don't think there's anything else oh, so for me, I don't like to process. This one, I did a little bit of Lightroom. I brightened the areas around the Milky Way that I needed to brighten, and I didn't do any merging. My foreground and sky are just the same shot. So, yeah. Okay, next slide, please. Okay, so I love this slide, but the settings were really terrible on my camera. As you can see, 16,000 ISO is really way high. And if you don't even have to look carefully at this photo, you can tell that it's really noisy. And there's really no way to remove the noise. I tried Topaz, I tried some other denoisers, and what happens is you start losing resolution and you start losing stars. So probably should have changed my settings. But anyway, once again, I didn't have to merge anything. The foreground and sky are the same. I didn't use it to tracker. It's just a 1 second exposure. This was taken in Finland. So this was pretty cool because I've only seen two different auroras, and they're both not really strong, I guess you'd say. But this aurora activity lasted for 4 hours at least. It probably went on. We left, we were frozen. It was -20. We're standing outside. And after about 4 hours, it started pulsating, which is, I don't know how many of you have seen auroras, but it's a light show. And my problem was I was such a novice. I didn't know what I was doing. And people who turned their camera to go straight up got those beautiful like auroras that look like hummingbirds or butterflies. I totally missed that. So I guess every time you take a photo, you learn something from it. And if I ever get to see auroras again, I'll do a better job of it. See, is there anything else? No, I think that's about it. Thanks, Chris.
All right, thank you, Peggy.
Sure.
So to kind of recap on our night photography section here, by the way, beautiful images, Bob, Heather, and Peggy. Um, you're going to need the following pieces of equipment. You're going to need a camera with manual controls, something that will allow you to set the ISO, the speed, and the f-stop. You're also, and that can be either a DSLR or a mirrorless camera. You're going to need a wide angle lens and a low aperture lens. So a wide angle typically would be anywhere from 14 up to 24, maybe even higher millimeters in terms of focal length. And then the aperture, you're going to want to have relatively low f-stop. So 1.4, 1.8, something that will allow you to open up the lens and collect a lot of light so that you can shoot for shorter periods of time. Sturdy tripod is a must, and then extra batteries and memory cards are going to be required as well. Optional features would be the star tracker. So as Bob showed us, you can take some great stuff without a star tracker, but if you do have a star tracker, you can take many more images and get more detail. Remote shutter release or intervalometer are necessary. The shutter release, again, allows you to keep from jiggling the equipment and getting some blur. The intervalometer is something you would need if you're going to do multiple images like you would with a star tracker or with the star trails. A dew heater would be good to keep moisture off of the lens. And if you're going to be shooting in suburban skies, light pollution filter might be something you'd want to add to the kit. Okay, so now we're going to move into astrophotography, and we're going to start out with a discussion on smart telescopes. And our first presenter will be Bill Riley. So, Bill, if you'd come off mute and walk us through the C-Star S50 and some of the images that you've taken.
All right, sure. Thank you, Chris. Hi, my name is Bill Riley, and this meeting is probably a good one for me because I'm still consider myself a novice. I received a C-Star S50 about a year ago and started taking pictures with it just in January. It comes, as you can see, it comes with a small tripod, which extends out a little bit, but and as it is, it's fine if you're taking pictures in alt azimuth mode. But since I purchased it, they have since included an equatorial mode. But to do that, you'll need a tripod, a wedge, of course. And I got a larger, more sturdy tripod as well. It's over here in the corner. Anyway, it's fairly intuitive. It's fairly inexpensive. I mean, this as it is, at the time I bought it, it was $500, and it's been great. It's essentially my gateway drug to astrophotography, and maybe we'll end up with another telescope soon. Anyway, that's all for that, Chris. All right, so the telescope as is, because it takes good pictures of deep sky targets, the moon and the sun, but it doesn't do well on planets because of the focal length, I assume. Anyway, this was the first decent image I took back in April. I happened to have taken my scope with me. If you saw the prior picture, it's very compact and lightweight, so it's very portable, and it's easy to. It takes maybe 10 to 15 minutes to set up and get it running. So it's easy to take places you wouldn't normally. You'd have to second thoughts on taking a big rig. This particular picture I took in alt azimuth mode before I started using an equatorial mount, and it was limited to 10-second subs at the time because of field rotation would occur if you took a lot longer using alt azimuth. Anyway, it was a very windy day, and I had to use a windshield to block it, but I was still able to get in 78 minutes worth of pictures on this M51 Galaxy. Go ahead, Chris. Over the summer, it was I was taking more and more pictures, trying to get in as much as I could, but although it was kind of cloudy a lot. This one I started taking in August, or actually before that, I started taking, setting up and using equatorial mode and increasing the length of exposures. This one was taken using 20-second exposures, and for 102 hours. And all I ever use so far, I haven't done any post processing on my pictures. I use just within the app itself. It'll allow you to denoise and adjust the contrast after you stack it. So that's what this is. Go ahead, Chris. I think there's one more. Yes, this was one I took at the El Dorado Star Party back in October. I was surprised I was able to get it with the scope. The Lemon, the comet here, I saw some other people taking pictures. They were warning to not take longer exposures than 2 or 3 minutes. And this one's made up of 8 minutes worth of 2 or 3 minute exposures. Well, I take it back. It was stacks, put it that way, 2 or 3 minute stacks of 10 to 20-second exposures. Because if you took longer exposures, it would broaden the and not look correct. It was thrown out because of the speed of the comet. Anyway, that's I think besides the telescope and the improvement in getting a better mount and wedge. I mean, and tripod. I think it's probably about $800 total
Excellent.
expenditure.
All right, Bill, thank you.
Mhm.
Next, we're going to have Cindy talk to us about the Dwarf 2. So, Cindy, if you come off of mute and tell us about your telescope and some of the images that you've taken.
Sure. Hi, everybody. I actually have to give credit to my husband Ricardo for buying the Dwarf 2. I didn't even know there was such a thing as a smart telescope until he bought this little device. And he got interested in it because he wanted to be able to image the solar eclipse that happened in 2024. So I would call this probably the less well-known competitor to the Seastar S50. It's about the same price range. It has a lot of the same capabilities. And as you can see, it's very small, very compact. It has its own little case. The tripod that you see in the photo there is that was a used tripod that we bought to put it on, and it's actually got a little equatorial, like a polar lined mount that we purchased for it as well. So it also has what you call an equatorial mode, so that you won't get that artifacts around the edges of your images. It will rotate along with the stars more evenly. This particular model, the longest exposure you could take was 10 seconds for deep sky imaging. But it also takes videos. And if you want to go to the next slide, you can see one of the photos we took. This was out in Lake Whitney, Texas, during the April 2024 solar eclipse. And we were able to film the whole thing. And this is one of the still shots that we had at the height of the totality. So that was just super cool. Ricardo bought a sun filter for it, so we could have a really nice memento of that particular event. It was great. And this is the native processing from the device, because this isn't stacked like you would do deep sky photography. This was just a still frame from the video that we had. So that's one of the nice things that I liked about the Dwarf is it's very you can do a lot of things with it. It has a lot of different features, and now they have a newer version. They don't make the 2 anymore. Now it's a 3, and they've actually upgraded a lot of things. You can do, we've used it and put it on a bird feeder for my dad, so he can sit inside the house and watch close-up video of the birds. It can take landscape photography. It can take sun, moon, and it can also do deep space objects, which is the next couple slides. So here's one I took last winter of the Pleiades. This was, I think, and I forgot to write down how many exposures it was, but I think it was probably around 100 10-second exposures. I just ran it until you couldn't see the object in the sky anymore. And the little device, you can actually take out the memory card and use the raw files, because you could save them as a TIFF file if you wanted to, and use your own processing software. Or the other option would be like on the Seastar, you let it will stack all the images for you, and it gives you a little JPEG file with a photo, and you can use that as well. But I chose to take all the raw files, and I watched some videos online. I learned how to use Ciro, which is a free astrophotography processing software, and made this little picture of the Pleiades. And then the next slide, a similar situation, same time of year, imaged Orion, just 100 or 150, however many I could squeeze on there, of little 10-second exposures. And then I took the raw files and stacked those in Serial, and you know, just had a lot of fun with playing around with the colors. Again, same thing. You'll get a pre-made picture out of the device like this, but you can get nicer results if you take a little bit of time and decide to do some of your own separate processing, because you have more control over the noise levels and the color, and you know, you can just clean it up a lot more. And then the newer model now, it has some additional features. Apparently, it comes with some nice filters. It has like a dual band filter. They've changed the lenses a bit so that you can also do wide angle Milky Way photos, and it now has an option to do panoramic landscape pictures. So it's a really cool device. Like if somebody doesn't want to just take sky photos, they're going on vacation and they want to be able to do a bunch of different things. It's really great for that.
Great. Hey, thanks, Cindy. Appreciate that. So let's just wrap up quickly on our smart telescopes, the C-Star and S50 and the Dwarf 2. The pros, hey, easy to learn and use. No system integration required. Relatively inexpensive. Long battery life, 4 to 6 hours. And as Cindy mentioned, with the Dwarf, you can do wide angle photography like Milky Way. One thing also I didn't mention here is the size and the compactness, which is really nice if you're going to travel. The cons, no eyepieces, so it's a completely digital telescope. There will be limited ability to grow and expand your functionality. Cindy did mention some narrowband filters that you can add. There's no extended storage, so you're going to get the storage that you have with the embedded multimedia card, the figures that you see listed here. As Bill mentioned, you do have alt-azimuth functionality out of the box, which will give you field rotation. However, there are ways to set it up to do equatorial photography. And also, the camera in these devices is not actively cooled like a traditional astrophotography camera. So you're going to get some noise from longer exposures. Okay. So with that, we'll now talk about integrated systems, kind of coming down the home stretch here. Heather is going to tell us about her setup here. So Heather, if you'd come off mute and tell us about your astrophotography rig and the image that you've taken.
Yeah, so this was a couple months after I got the telescope. It's the same Canon EOS 1100D. Basically, I got it's just a T adapter. It's a Celestron T adapter. You can get it on Amazon or a Gina or whatever you want. And then it comes with a little T ring that's either a Nikon or a Sony or whatever. Plug it in, attach it to your telescope. It's pretty simple. I also have the f6.3 focal reducer attached. So you basically take off your visual back, you screw on your reducer, and then you attach the T adapter to the reducer and then the camera. If you have a big SCT like this, you 100% want to get a focal reducer. It takes it from f10 to f6.3, and that makes a huge difference when you're trying to image, you know, the dimmer objects. It also kind of shrinks stuff down a little bit better. So yeah, and it's on its Nexstar fork arm mount. It's not equatorial, so you're going to have some field rotation. I image from my apartment balcony, so I don't get a full sky anyway, so that's never really been a problem. The biggest thing with this one is I did actually didn't attach, but I started running it through software. So you can see the computer on the right. It's just my laptop from work. I downloaded CPWI. It's Celestron software to control their mounts. It's free. You basically plug your hand controller, you get a USB, attach hand controller to your computer, and then you can run it. It lets you do your star alignments. It lets you control the slew, all of that from the software. And then the camera is also plugged in via USB, and I run it with Nina. It's nighttime and imaging astronomy, free software. So that way I can see what I'm looking at with the camera instead of looking at the back of the tiny little LCD screen on the back of the camera. I can see it on my laptop. It's really easy to set up. There's tons of tutorials online. It also, if you are using a telescope like this, like a Nexstar, it makes it a lot easier to set it up initially as well. So you have to do things like star alignment so that you can get your go-to calibrated. And if you can use a live view on your DSLR and the big screen with the target on it, you get really good, precise alignments doing it that way. Yeah, and then I would just use the image sequencer to set up, 200 10-second subs and then let it run. And another thing is, if you are using this type of setup, you're going to throw away a lot of subs because it's going to drift a little bit and it's going to move and it's not going to be perfect. So while you're doing your image sequencing, you're going to have to kind of nudge it, keep it centered. You're going to lose some subs, but that's just kind of the nature of using Alt-Az without auto guiding. So if you want to go to the next one, to the picture. So this is Orion, obviously. This is after I got my Canon Astro modified. So it was about $175 through astrogear.net. Like I said, the DSLR was already very, very used. So it really wasn't a big, investment for that end. I don't even have a filter on the camera for this, I don't think. But ISO 1600, 12-second subs. I probably did 30 minutes max because it's so bright. When you're shooting Orion, you want to try to do an HDR stack so that the trapezium, which is the really bright core, kind of right at the left of center, you don't want to blow that out, but you also want to bring out the dim nebulae around it. So what you'll do is take, 25-second subs and then 30-second subs and then some 60-second subs if you can. And then you'll use a software to kind of do that layered effect. So I used Deep Sky Stacker at that time because it was free and I didn't know how to use PixInsight yet. And then processed it in Photoshop. And I processed this following tutorials from Nebula Photos on YouTube, Nico Carver. He does a bunch of tutorials on using DSLRs and Photoshop. So if that's what you have to get started, I definitely recommend his website. And this is basically as simple as it gets, camera attached, take pictures and stack. So yeah, but go to YouTube.
All right, Heather, thank you. Moving along here, here is a arrangement that comes to us from Jeff Schilling. He's actually not in the club, but he shared this with me, and I thought it was pretty unique because Jeff's not using a telescope; he's using a telephoto lens, a Samyang 135. So he's got a very wide field of view, very small aperture, not even 70 millimeters. And then he's been able to attach to it a ZWO camera that you see down here, the 1600 mm Pro. And I think that's a monochrome camera. The one thing I want to point out here, you noticed in the previous presentation, Heather had a laptop. Jeff actually has an ASI Air, which is kind of like a mini computer, and he's able to connect his phone or his iPad to this and control his rig from that. So it kind of gets you closer to maybe that smart telescope functionality that we saw earlier with Cindy and Bill. Anyway, kind of a unique situation here, and this is what you can do with it. So the Cygnus loop is a very wide field of view object. Even my rig, which I'll show you here next, is wide field of view, but I can't capture this much space. But you can when you have a very short focal length like Jeff does with his telephoto lens. And it's a beautiful image. He's got the Eastern Veil Nebula and the Western Veil Nebula all in the same picture. Here is my rig for astrophotography. I use a refractor telescope. It's really just kind of a glorified telephoto lens if you think about it. It's a Takahashi FS60B refractor, so it's a 60 millimeter aperture or opening. I can configure it to 3 different focal lengths, 29, 30, 355, and 603 millimeters. It's currently shown here in the 249 millimeter mode. And I got this Skywatcher here, and that is a piece of pig iron. That's the one thing that kind of keeps me from doing more astrophotography is picking this thing up and lugging it around. I've coupled that here, not in this picture, but over here with a ZWO one-shot color camera. The back end here, you can see the plugins that you would use to connect the camera to the computer. I use a laptop, and then the power right here. And there's a cooling fan in here, and there's actually active cooling inside the camera. And then here's the sensor that actually collects the images. So that's the equipment. And then here's a sample of one of the images I've taken. It's a Pleiades at M45. Took that out at the dark site. Um, the gain of 100 is right around the sweet spot for this camera. I take 60-second images because I can pitch them if they get satellite trails or planes through them, etc. And in this particular case, I took about over 3 hours of pictures, threw away 13 of them, and used 177. I used a UV-IR filter to cut out the both ends of the visual spectrum, but I got it was a broadband picture because of the colors that I wanted to capture, and I used PixInsight and Lightroom, and one of my favorite images, so I had to share it with the gang. Now, last but not least, our incoming president, Matt Borlange, is up. And Matt, tell us all about your rig and your picture.
Thanks, Chris. So this is my telescope. So I didn't start off with the whole system like you see here. I built it up gradually over time. I actually made a little bit of like a roadmap to get there, starting off with a star tracker and a refractor, and then gradually upgrading individual components to get here. Um, what you see here is a harmonic drive mount. That is the AM5 from ZWO. There are a couple of great alternatives also on the market that do the same thing. It's very lightweight and can handle a lot of payload. So this is great to do imaging with some mobility needs, like putting this in your backyard or drag it over to the dark side. On top of that, you see a Newtonian. So that's almost like that's like a Dobsonian, but then kind of functions on the same way. There's like a mirror in the back, and there's a secondary mirror at the front, and then it kind of beams out the light to the camera that you see sticking out below. And that is a mono camera, so that MM stands for mono. And there's like a filter wheel in front of it that you can choose different filters for. So you have luminance, which is basically an all-pass filter. And then you have RGB for red, green, blue. And then you have a narrowband filter for sulfur, hydrogen, and oxygen, which are the emission lines of nebula typically. So this setup is great if you are working in a light polluted city or a light polluted backyard. The mono sensitivity and the narrowband filters are really robust against quite some light pollution. So we have a lot of members in our AP-SIG that are really imaging from downtown Houston and are able to come up with amazing images. Of course, it always gets better if you get out to the dark side. So the other nice thing about mono is that if you're interested in expanding beyond photography, so do, for example, variable star photometry, or you want to look into exoplanets, then a mono camera is also really nice to use. So I use the same setup for exoplanet verification and for variable star photometry. So yeah, that is my setup. So the focal length is a little bit deeper than the other ones that we've seen today. So it's like almost 800 millimeters, and it's a Newtonian, so it's a big aperture, so it's very fast. It's like almost an f4 scope. So yeah, this is the next one is the image. So this is in Cygnus, it's the Crescent Nebula. And this is an image in narrowband. So this is a HOO image, which means that a typical RGB, red, green, blue image, you're replacing the red with H alpha and the green with oxygen and also the blue with oxygen. And then you get this kind of false color image. But what is really cool to see here is the hydrogen, so that the red background emissions of the nebula in the background, and then the huge kind of waves around this Wolf-Rayet star in oxygen. So you almost really see the explosion happening in front of you. And this was one night from my backyard. And then because it's narrowband, you take very long exposures. And this was processed in PixInsight with some plugins for further detailing. Yeah, that was it. Yeah.
All right, Matt, thank you very much.
Mm.
So, a little bit about pros and cons of integrated systems. Pros, you're going to get you can get high quality imaging with the mounts and the tracking and if you employ guiding, which I didn't talk about much. I didn't talk about it all, but you'll notice I had like that little secondary telescope piggybacked on my telescope. I can guide, which gives you more accurate, lower error tracking, which allows you to take more subs and longer subs. Astrophotography cameras, in particular, have high quantum efficiency. In other words, more photons are converted to electrons. And you've got active cooling, so you can really reduce your noise reduction, take longer subs, etc. They're flexible. Systems can be reconfigured for a wide range of targets and ease of control. So if you're using a laptop or even the mini computer, you can use packages like SharpCap, Nina, and Stellarium to control your mount and your camera. So it's really nice. The cons, these systems are expensive. So, and I can vouch for that. System integration and troubleshooting is required. Again, I can vouch for that. I spent a couple of nights around Christmas about 3 or 4 years ago. My wife thought I was nuts, but I had to get it to work because I was so inspired. And then you're going to be learning a lot of software, so that's going to be a challenge as well. Here are the components that you want to consider if you're going to put a system together. So you're going to need a mount. You're going to need a mount that is that's steady and can handle the payload that you've got. You're going to need a camera, either a astrophotography camera or a DSLR or mirrorless camera, like we talked about earlier. Obviously, you're going to need a telescope or a telephoto lens. You'll need a computer or a mini computer like that ASI Air. You need a power source. Now, if you're out at the dark site, there's power out there already for you, so you don't need it in that case. But if you're out in the wilderness, you're going to need a power source. Dew heaters to keep the moisture off of the lenses of the telescope. You're going to need that. Filters, especially if you're doing monochrome filtering, you've got to have, or monochrome camera, you're going to have a set of filters to do the various colors of shots that you're going to take, and a batten-off mask to help you focus your equipment. Optional equipment, auto guiding camera and telescope. For I would say that almost falls in the required area, but if you got a really wide field of view, you can get away without it. But recommended to have that. A filter wheel in particular, like Matt was talking about, if you're going to do monochrome imaging, you're really going to want to have that for convenience. And then an autofocuser is another feature that is really a good item to have because over the course of the evening, temperatures change and focus will as well. Okay, we're running a little bit late, but we're almost there. I want to wrap up with a gallery walk, and what we're going to do is show you some of the images that others from the club had submitted. Also, want to play some nice soothing music that I think goes along with the images. So just kind of sit back and relax and take it all in. And I've got my sound on my computer turned up to the highest level, so hopefully you'll hear the music. So I hope you enjoy it. All right. Well, I bet you thought you weren't going to get serenaded at a novice meeting presentation, but I think we pulled it off. And anyway, we're going to wrap up here quickly. Just some general parting advice. Answer those important questions. Help you get yourself on the right track. Once you got some experimenting under your belt and you're ready to go out and do some serious imaging, plan that project. Know where your objects are. Know what your foreground's going to look like. Know where you need to set up. Start simple and get some wins, then raise that bar. Like I did with that moon shot. That was a simple win. It was a knockout. It got me really enthused and it got me to the Pleiades. If you get stuck, ask for help. We've got plenty of help in this club, and people are more than willing to share their knowledge. And then build your system out when your confidence and your budget permits. I want to just recognize the contributors for the presentation tonight. So, Matt, Steve Brown, Heather, Steve Goldberg, John Haynes, Kenrick Katner, Bob Menius, Peggy, William, and Cindy. And then we had some non-members that contributed as well. Jeff Schilling, Jeff Smith, and Don Taylor. I want to thank everybody that submitted their work for the presentation. And I really want to give special thanks to Matt, Heather, Bob, Peggy, William, and Cindy. A lot of great suggestions, feedback to me to really put together something I hope was special for you tonight. And anyway, with that, I want to just wrap out quickly. Uh, well, again, thank you very much, folks. I really appreciate your input and your contribution tonight. So. Presentation, Heather put the link in the chat so you can get it there. If for some reason you don't get that, you can send me an email and I'll send that link to you. And then I've also included a presentation from a few years back that Don Selly did on night photography. It's a great way to kind of get your hands wet, get started with night photography. So take a look at that. And with that, I want to thank you and ask if we'll go and talk about questions now. So let me open up that chat, and I'm gonna kind of leave the presentation up there. Let's see. Steve Brown, Night Images on YouTube channel is a great resource for starry nights with foreground, especially his older vids. Heather's got the solar can. Let's see. Let's see. Peggy, can you use a 2 second delay on your camera? I'm not sure. So Peggy asks, Peggy, why don't you come off of mute and talk to us? What was your comment about the 2 second delay versus the intervalometer?
So I think on one of the slides you were saying that um, some equipment you might want to have as an intervalometer or a automatic shutter release. But I found carrying all that stuff around, it's just as easy to put a 2 second delay on your camera so you don't shake it, right? You hit the
Oh,
button, and 2 seconds later it goes off.
okay. In other words, just don't use the remote shutter release. Is that what I'm hearing?
Right,
I got it.
right, yeah.
Okay. Let's see. Peggy asks, what was the distance from the Dobbs to your camera for the moonshot? And how did you know what the distance should be? You're talking about like the back focus?
Yeah, because when I've tried to do this with my Dob, I can never get the moon in focus. And I have
Yeah.
a Barlow. I've tried a lot of different things and I just can't get it to focus.
So the short answer is dumb luck. I bought a Barlow and it worked perfect.
Okay.
And then I tried to do it without the Barlow and it really didn't work that well.
Yeah.
So,
Okay.
but dumb luck, sometimes that's your best friend. Uh, Okay, so Heather, can you ask about a photographer on the internet with you would recommend for processing help? Are you
Oh,
there?
yeah, yeah, yeah. Yeah, so for like the solar can.
Well, you got it looks like a question. You said who was the photographer on the internet that you
Oh yeah.
recommend?
I
Matt
asked
responded.
that.
It's Nico Carver. Yeah.
Oh, okay. Matt answered your
Yeah, it's
question.
the Nebula Photos channel.
Got oh, and you said thanks. So we're all good there. All right, good deal. Let's see. Let's see. That's Christian says thanks to all presenters. Excited to check out all the mentioned products and try a few of them myself. Well, thank you. Heather asked, does the solar can work with a pinhole camera? And how is the film developed? And Heather, you answered that,
Yeah,
right?
it's just
Okay.
yeah, it's comes with photosensitive paper, not necessarily film. So when you get it out, you can actually see it on the paper. You just have to scan it on a printer, and that's it. You don't have to send it off or anything.
I gotcha. All right, I think that's all the questions here. If anybody's wants to just come off mute and ask your question, please feel free.
Hey, this is Sean, a relative newcomer. Just wanted to thank all of you. This was far more accessible than I thought it would be, both in terms of money, but also locations that you were shooting from. So I was pleased to see that. And Heather, I just got to tell you, I love the Hitchhiker's logo on the side of your telescope.
Thank you. That's the first thing I bought as soon as I got it.
um, you
And
mentioned
I had
there's a
to move
link.
it when I moved my telescope from the fork arm to an EQ mount, so I had to pull it off and get a new one. Put it on.
It's awesome. I'm not
Thanks.
seeing a link to the slides. I think did you mention that was supposed to be in the chat?
It is. It should be at the very top.
I just reposted it. Yeah.
Oh,
Okay,
did
thank
you?
you.
Okay, Matt reposted it.
Yeah.
Thank you so much.
All right, excellent. Any other questions?
Can you hear me?
Yes, we can, Brian.
Okay. Well, thank you all for the presentation. I live about 50 feet from Buffalo Bayou, and in the daytime you'd think we were in the middle of the jungle, but at night there's like tons of air, light pollution here. Is there any hope for me?
Is there any hope for you?
Yeah. Well, I mean, should I go like with something start like a C-Star or the Smart Telescope or? What direction should I go? Because at nighttime, there's lots of light pollution.
Yeah. Can I answer, Chris?
Go right ahead.
Yeah. So yes, there is.
Yeah.
But it's of course you want to go to the darkest place ever. But if you're interested in nebulae, nebulae have a very narrow emission, very particular wavelength emission. So it comes down to making pictures with a very narrow band filter, and then you can reject most of the light pollution. The C-star filters are relatively broad narrowband filters, but that means that you need a lot of time, a lot of exposure, but it can be done, and you will get an interesting picture to start with.
Okay.
But if you want to get further, then you have to uh, grow further with your equipment, and then the game is to get the most narrow band filters that you can get your hands on. And there are people with 6 nanometer um, uh, narrow band filters that
Hmm.
have good success making pictures from Bel Air right now in Houston in our club. Very, very feasible.
Okay. Interesting.
And I thought I heard Cindy say that there are narrowband filters available for the dwarf. Is that correct, Cindy?
I wasn't totally sure. I was looking at their website and they called it a dual band filter.
Yeah.
Um, I think it was HA and O3. So I mean, I use the dwarf too from my backyard here in Houston, and I live across the street from the University of Houston, which is so, and I was still able to take pictures with it. you have to take a lot more exposures and
Mhm.
work a little harder to process them, but you can take pictures.
You just got to pick the right targets too. Don't go
Yep.
for like, a dark nebula. Go for Orion or
Orion.
Yeah.
Rosette
And,
or
and Orion's
Pallid.
coming up. So
Yeah.
Orion, between
Mhm.
now and March, Orion's a great target.
It's a great
And Pleiades too. Pleiades is a
Yep.
very bright object as well. So
Yeah, globular clusters turn out pretty well in bad light.
Yeah, they're so bright.
Yeah.
Those are some of my favorite.
Yeah.
did that answer your question, Brian?
It did, thank you. Yeah.
All right, excellent. Anybody else have any questions? Okay, I'm going to take that as a going once, going twice.
Not yet, not yet.
Steve's got a question. He beat the
No,
auctioneer.
I just have a compliment on the host show. It's a very good presentation of different types of objects and methods to do it. So I just want to say thank you.
Oh, well, thanks, Steve. It was a group. It was definitely a group effort. Um, that gallery walk was not something I had thought of, and then Bob suggested it, and I'm really glad we put that together. So,
Yeah, and
um,
you had my movie in there too.
yeah, I snuck you in there. Okay, any other questions or comments? But I've got one quick announcement before we wrap up, and then I'll turn everybody loose. Going once. Going twice. Okay, I'm going to call that a no more questions. Be sure to tune in tomorrow night. The general HAS general meeting will be a Zoom meeting, and the topic is modern astronomy research, data driven, and this will be by Dr. Jimmy Newland. And I think it's a very apropos topic because with the Vera Rubin coming online, and the amount of data that they're collecting is just astronomical. And in order to collect it and sift through all of it, data and analytics has just come to the forefront. So, anyway, if you can make it, please do. And with that, I thank you all for joining, and I wish you all a Merry Christmas and a happy and prosperous 2026. Thank you.